Pseudocode for partition algorithm. Partition algorithm is an algorithm which takes in an array, chooses any of its elements and calls it the pivot, moves every element which is less than the pivot to the left of the pivot, and every element which is greater than the pivot to the right of the pivot. It will return the index at which the pivot has been placed. If we were to write the algorithm for partition, it will take in an array, say A, the start index of the array, and the end index of the array. The first step of the partition algorithm is to choose a pivot. The pivot can be chosen as any of the elements of the array. For convenience sake, we are going to take the pivot as the last element of the array. Next, we must have a variable called pi which stores a potential pivot index. In the beginning, we will say that this potential index is the start index. Now, we must traverse the array using a variable I from the start index up till the pivot. So we will run a loop with counter variable I. It will start at index start and it will end at index end minus 1. At each time, we will increment this I. Now, for each element at index I, we will have to check whether the condition that pi is the correct index has been violated, and if so, do the necessary changes. How do we check if the element at I violates this condition? If the element at I is less than the pivot, then we say that the condition has been violated. So let us write down that condition. This is the condition if the element at I is less than or equal to the pivot. The necessary changes made were to swap the element at pi and I, you can write the necessary code for this, but this is a pseudo code, so I am going to leave it at swap pi with array of pi with array of I. After that, we have to increment pi by 1 and with this our condition ends. This has to happen for every element of the array. So this will go through the loop. Now, once I reaches end, it will come out of the loop. So once line of code over here is executing, I will be equal to end. Once we have checked every element of the array up till the pivot, we must swap the element at array of pi with the pivot, or we must swap array of pi and array of end. Once again, this is a pseudo code, so I am only going to write swap a of pi with a of end. Once that is done, we have to return the index at which the pivot has been placed. So we will return pi. With that, our partition algorithm will end. If you take that the array has n number of elements, then the loop over here will run n times. Therefore, we can say that this function is of order n. So the big O notation of this function, that this algorithm is order of n.